Hey everyone, thank you so much for checking out another episode of the Weaviate podcast. I'm super excited about this one. We have Jerry Liu, the creator of GPT Index, and Weaviate CEO and co-founder Bob Van Light. So firstly, thank you both so much for joining the Weaviate podcast.
Thanks, Connor. It's great to chat.
Great to be back on, our own podcast.
Awesome. So Jerry, could we dive into the origin story of GPT Index? What led you to create this incredible tool?
Yeah, for sure. So, these days, GPT Index is a primary tool to build an interface between your large language model and your external data. And this seems to be a problem that's resonated with a lot of people in the community. And when I first started playing around with LLMs about a few months ago, I was actually trying to build a basic sales bot. So basically, ingest some of customer conversations from Notion, Salesforce, Gong, etc. And I wanted to use the generative capability of LLMs on top of this data to actually build a to-do synthesizer for me for the next meeting. So basically do some sort of meeting preparation. And of course, whenever you try using this amazing technology on your own data, the first thing you run into is the token limitation and the cost per token, right? So one of the things that you basically have to figure out is, okay, well, DaVinci right now is 4,000 words. How can I actually stuff all this information into the prompt so that it has the context to actually synthesize the information that I want? Now, 4,000 words is actually a decent amount for, a cache, but of course it's not enough to feed in your entire database of information. And that leads to, figuring out how to build interfaces for stuff like chunking, for stuff like being able to do better retrieval so that you can actually craft the prompt in a way that actually solves your task. And so I started this off as, a design project, built this thing called a tree index, which basically hierarchically built a tree over your external data that you could then use GPT to look up afterwards. However, I think since then, it's grown from a design project into an everyday tool that people are actually using on top of their LLM projects. So I think that part is super cool to see, and I'm very excited to watch it develop more.
I love to learn more about the tree that you're building. So it's like you just went over it very quickly, but just I remember that we had our first call and that you talked us through it, and it was like super exciting. So can you talk a little bit more about what you're actually doing there, like at the core of GPT Index?
Definitely. I mean, again, I think I just want to emphasize that started off as a design project, and it's one of those things where I kind of just made it up into something that I thought was pretty cool. I think these days, practically speaking, there's a bit of limitations practically in terms of actually using a tree on top of large corpuses of data. However, the paradigm that I basically started with was, okay, so you have this big corpus of text. Now, what if you basically just hierarchically built a tree over this text? So what happens is, let's say you take every 10 pieces of text or 10 paragraphs, and then you build a summary over every 10 paragraphs. Then you build the next set of parent nodes on top of this. Then you build a next set of summaries over these summaries that you just built. And then you kind of build the tree all the way until you have a set of root nodes, right? And to me, this is one way of almost like information compression, such that you basically build some sort of data structure that you can then use with GPT afterwards. And so, when GPT wants to look up a piece of information, it can start from the top and then go down this tree to actually find the information that it wants. And, if you the way we built this was quite naive and simple. It was just, aggregating every 10 chunks and building this like hierarchical tree over it. You could imagine this generalizing to graph structures, which actually GPT Index supports through kind of more sophisticated means now, and basically building a knowledge graph over your data and using this knowledge graph and leveraging this knowledge graph to actually feed into GPT. So the way the tree index started was, again, just building hierarchically over a set of text. And then when you actually want to send in a prompt or query, you can start from the top and then of the tree and then go down until you actually find the pieces of information that you want. These days, I think the thing that works the best actually probably isn't the tree index, though, it was a cool thought experiment. And we do use parts of that, and you see parts of that live on through other pieces of the tool. These days, the most basic thing that people start with is, you take in a corpus of documents, split it up, embed each chunk, and then throw it in a vector store, right? So like Weaviate or another vector store, and then during query time, you just retrieve top K, documents or chunks by embedding similarity and put it into the prompt. And so this has a bit less structure than, for instance, something like the tree index or a knowledge graph, but actually works surprisingly well for probably, I would say, like 40–50% of use cases, right? Of like basic queries. But I think this idea of the tree index, which then generalizes into this idea of like defining a composability and knowledge graph of your data, is now quite has the potential to allow you to define more complex structures of your data, as opposed to just kind of random, like just fetching different chunks through embedding lookup.
Yeah, so maybe I'm still kind of wrapping my head around the knowledge graph extension as well as this whole kind of top level index thing. So let's say I have podcast clips as like the example that I've been using to think through these things. So if I aggregate say 5 at a time to form a summary, and then from there I'm going to summarize those to like summarize the next thing. So when I'm searching through this index, am I first searching? So say I'm trying to find just a conversation segment. Do I first search through all the summaries? Then I search through these intermediate summaries. Like, can you kind of take me through like how the search works through the top level index?
Yeah, so there's a few points here that I do want to address. Taking a step back just really quick, the GPT index is always evolving as a tool, and going back to the high level vision, it really is about building this interface and thinking about what exactly is the best interface and a set of tools that we can give users to, build some structure over their data to solve their tasks. And so a lot of the tools that you see within GPT Index today are manifestations of that. So stuff like, we offer integrations with vector stores. We offer the ability to define graphs on top of your data. It's possible as these models evolve and, as considerations come in, for instance, stuff like latency and cost, these structures will also evolve. So take what I'm saying right now with like a slight grain of salt, in that I think we're still very much optimizing towards, okay, what exactly is this like best structure of data that accounts for, again, latency, cost, and performance, and that solves a broad range of different use cases from customers and enterprises. So with that said, one of the things that we thought about in the beginning was to and this is something that we've heard from users of GPT Index is, uh, it's hard to kind of feed like high level context into, for instance, like a text chunk as an example. So when you take in a document, and if you just naively, split it up, and now within each text chunk, you kind of lose some information about what the entire document is about. So going back to an example of, say, like a book, if a book is divided into different chapters, or actually maybe a better example is like a research paper. A research paper is divided into different sections like intro, related work, methodology. And then within each section, you're going to have subsections describing different components of each section. Now, if you split this entire text up into different chunks, and let's say you just have like section 2B and some random slice of that, you're going to not really have information about how this relates to the rest of the paper. So one pain point that this idea of defining a graph over your data can solve is that you can kind of like hierarchically build, or you kind of have this like hierarchy of context, both like very fine-grained context and then also kind of like higher up context with the summary. And so one use case that GPT Index with these graphs allow you to do is, let's say you do, say, build an index for every subsection of your paper, and then you build an index for every section. Like, so you set a summary for every intro, like related work, methodology, and then now when you actually query this kind of parent top level index, it can both retrieve specific sections of text that are relevant to your query, but also refine it with higher level context. And this happens because you're able to define a sort of graph over your data. Another use case of this is, again, what does defining a graph over your data mean? At least in GPT Index right now, it basically just means you can define like indices on top of other indices. And so another use case that this could solve is let's say you define a subindex for every data source. So let's say you have a collection of call transcripts in Gong, and then you have a collection of notes in Notion, right? And let's say maybe you have some conversations in Slack. Now, when you want to ask a question, let's say you explicitly want to synthesize an answer across all three data sources. Now, what you can do is you ask this question and you define a subindex for each one of these data sources. And then you define this like higher level index at the top level. And now when you ask a question, we just route this question to all three of these data sources. And then we combine them with this top level index, for instance, using one thing that GPT Index offers is like a list index data structure, which is synthesize an answer across every single node in its structure. So basically, this allows you to just combine information from all these different sources into one response. So it's quite an interesting thing, Like I think people are still experimenting with different use cases of such a structure, this idea of a knowledge graph. But the idea of just like being able to define some sort of like hierarchies over your data has proven to sometimes yield better results depending on your use case.
Very interesting. I have a question about like a term that you keep mentioning. You keep using the term knowledge graph, and I find it interesting because that has kind of a it's of course already also kind of an older term, if you will, was also very much related to the semantic web. And I think that if we talk about knowledge graphs today, or like the traditional way of talking about a knowledge graph was mostly also related to just having nodes in your graph, and then just having fixed relations between them, maybe like using Sparkle or those kind of things. One thing that I find interesting, and in Weaviate we also support like simple graph structures, right? So you can just make cross references, and sometimes I also use the term knowledge graph to talk about this, right? That is like, it seems that there's like a change happening where the nodes in the graph are not just on a 2D plane, right? So just like a graph and then relates to another one, but that we actually placing these nodes into the hyperspace that these models give us through these embeddings, right? So the question I think I have, and a little bit speculative, but could it be the case that the sorry, that for example GPT Index, or in combination with like a vector store like Weaviate, could be like a new revival of the knowledge graph, like the knowledge graph 2.0? Or would I be too ambitious if I would say those kind of things? Curious what you think about that.
Yeah, I mean, I think conceptually that absolutely could be the case. I think there are a few practical limitations and challenges that we would have to solve to make this work. But there are already components that you can kind of see within GPT Index, and you could totally integrate with the backend store like Weaviate. So there's the part that GPT Index supports right now is given a user-defined graph. Let's say they construct it within GPT Index tools, we can then kind of perform operations over this graph, right? We can then have a query and route it through the knowledge graph to get to the right information that it needs to answer this query. There's also this separate component of knowledge graph construction, right? Which right now, users have to build a little bit manually on top of their data, at least within GPT Index. And I think it's also a very interesting question to think, hey, what are ways to basically infer a knowledge graph, right, from unstructured data? And maybe we can generalize beyond this idea of like a knowledge graph. Just going back to the mission statement of GPT Index is like, what is the best structure over your data that we can infer? Most of the world right now, or at least in terms of data infra, lives on structured data, right? And then now, of course, there's a lot of stuff taking off around like unstructured data paired with vector stores, and then there's this idea of knowledge graphs. And so figuring out, how to extract, for instance, like entities from this data, either in a structured format, in a graph format, or as like raw unstructured text. I think these are all very interesting questions to think about, and you could totally use GPT to at least in the ideal state, to automate a lot of this ingestion and transformation. And so I think that is absolutely something that, especially as these models improve, like GPT Index would want to be at the forefront of. So I think like there are really these two components, and right now one thing that GPT Index does is it allows people to define graphs on their own on top of their data and be able to route queries through these structures. But I think the line of work that we're very excited about improving is how can you infer different types of structures. One thing that GPT Index does offer right now is we can allow you to pass in your unstructured data, and we can actually infer structured data points from that and put it in, for instance, like a SQL database. One line of work that we do want to do is do a bit more in terms of thinking about how to best ingest and store unstructured data in different formats, outside of just like naive text trunking, for instance. Right. And so one feature that users have asked for is, oh, how can I inject like global metadata into each unstructured text trunk to preserve some sort of global context?
No, I have a quick question about it because I find it so intriguing. So Connor and I, we did a little bit of research also with the we were looking at like creating feedback loops also with the database, right? So that you have a query that goes into Weaviate, and then what we currently do with the generative part is actually it goes into Weaviate, and then you get like your candidates, and then you pump that through like or pipe not pump pipe that through a generative model, and then you can give it a prompt, right? You can give it a task. And what we were playing around with was that we were saying like, can we also ask the model, for example, like to just do another query in Weaviate? And as part of the prompt, we basically said like, we want you to populate this JSON object, right, with this key and this action. And to my surprise, I was just maybe I don't know. I was just flabbergasted that it actually did that. But you remember that we worked on a Connor that it presented the results as a JSON object, and they were like, but that's amazing because then we can really have like more functional, do more functional things with the model. So the reason I'm bringing this up is I would love to learn. You said something so interesting about like how you're looking at having the LLM help in creating the structure. Would it be something similar as that I just mentioned, or is it something completely different?
Oh, 100%. I mean, I think that would it's actually a pretty interesting way to try to get LLMs to infer different types of data. The use case that GPT Index does right now is it infers structured data from unstructured data. I have seen people play around with different tools. I'm sure you've seen this too, where you just ask GPT to, hey, just like store context within the prompt itself, and then just give me back like another JSON object also in the prompt. And so you just see in the prompt, you just feed in like your entire like JSON object, and then it'll give you back a new JSON object, for instance. Um, I think, I think these are things that we're experimenting with. I think there is probably like a few limitations to, for instance, just like storing context and state within the prompt entirely, just because again, due to like token size limitations. But if you can somehow again maintain some sort of structure and then have GPT Index be able to both read the structure and be able to know how to update the structure, and the structure is maybe stored outside of the prompt itself in some format but then you can feed parts of it into the prompt. Then that part is very interesting to think about, because I think, like imagine you maintain this JSON structure, but then you are able to feed parts of this into GPT Index, still obey the token size limitation, but it provides GPT enough context to help update and insert new elements into this overall structure. I think that's going to be really interesting. There's also stuff around, for instance, like knowledge graph inference, which, like imagine, given this content, you can extract like entities from this content, and then you can then infer relationships between the entities. And now, there's this cool project called like Graph GPT, where I think it was this, front end visualization, and they had this like nice front end. But what they did was they basically, took in this user query, and then basically directly asked GPT to infer the structure directly within the prompt. So like kind of like given the output, it should infer all the relationships within the data that you feed it. I think that's also something I've kind of been interested in for GPT Index, but maybe extending that to also storing the structure outside the prompt itself. And then, given some unstructured data, like start building up some knowledge graph over your entities within this structure that you can then, query over with GPT Index. So, lots of very interesting things around not just like the query side of things using LLMs, but also actually how to construct these types of structures using GPT as well.
Yeah, wow. When I think of knowledge graph, I also think of this like like Connor lives in Boston, works at Weaviate, like that kind of structure where it's the data structure is to collapse the entities into the single thing. It's making me think about like so if I have like coming back to the podcast clip example, I might extract the entities and then use that to go get the facts and then add that to the prompt. That kind of thinking is yeah is what is inspiring me. But it kind of, if I could come back to something else you were saying about the integration of different data sources like Slack, the calls, these kind of things, and it makes me think that like so in Weaviate usually the thinking is we would divide these up into different classes, and so then just the atomic units, each of them lives in their own vector index, like based on this is the Slack vector index, right? So are you taking all the atomic units of all the different data sources and putting them all in one kind of vector index, and then you build up the hierarchy from there? Like how does the kind of chunking of atomic units and index construction happen?
Yeah, that's a good question. I think, it makes sense to me for all these different data sources to be stored in different structures. So, for instance, if there are different Weaviate tables or just like different, indices, I think what we would do is we'd probably want to maintain that structure. So we don't want to like, collapse all the data into one table on our end. But what we'd probably want to do is, let's say you have use cases where you do want to, for instance, like synthesize a response across all three different data sources, or you want to route a query to the best set of data sources that can best answer your question. We want to, treat, for instance, these data sources in Weaviate as three different subindices, and then allow you to build some index structure on top to actually solve your use case, whether it's summarization or routing for question answering.
So then that routing, that's the LLM tool use where you tell it, hey, you have, Slack conversations, blog posts, right?
Oh, kind of. Yeah. So there's different ways you can think about this. One is you can directly do this within GPT Index itself. It's actually part of the graph. So just imagine like a parent node that's at the top of the graph, and then each child node is like your different data source. So you have like three child nodes: one Slack, one is Notion, one is Gong or Salesforce. And then you can have a parent node at the top that acts as a router. So then you can actually, given a query, like pick and choose which of these child nodes is most relevant to your query. You can also actually integrate this with kind of multi-step agent behaviors. And, for instance, like LangChain has an agent abstraction where you can actually act in some sort of multi-step manner and can choose between different tools. Then, you can also have these different sub-indices be tools that this agent could choose from. So part of it is just dependent on which abstraction layer you want to build at. If you do want to kind of wrap this entire thing around a GPT index like data structure, you could to solve your use case.
Yeah. So yeah, I think the agent thing is a whole conversation. Like, because I don't want to get too off of just kind of understanding the sub indices and all that, but maybe if we could come into just the tool use, the external APIs, and all of how that's integrated with GPT Index.
Yeah. So sorry, just to clarify, do you mean like the LangChain tools, or do you mean?
Yeah, so I think kind of I've been so I'm still sorry for the slow response. I'm still trying to like process the understanding of the sub indices and all that. But so I think in addition to the sub indices, which is like a data structure, there's also like the tool use. Am I correct in thinking that these are two separate things, like the LLM tool use and then sort of using GPT to create these indices? Are those like you see those as separate?
Yeah, so I can try to help clarify this a little bit more at a high level. I know the way I described it was probably a little bit complicated, but basically, in my mind, imagine GPT index like a data structure, like quote unquote. We have that term. Just imagine that as an interface to your data, and so imagine that entire thing as a black box, right? So you give in some question, and at the end of the day, you want to define a structure so that you get back the response that you want. right? That's kind of everything within that box is that data structure that we allow you to create. So if we just operate purely within the tooling of GPT Index, going back to that example of having, for instance, like sub-indices, what I mean is, let's say you define like a separate index data structure for, all your Notion notes and then also your Slack conversations, right? Now, what you can do is you can actually define, say, like a top level data structure over these, sub indices or individual data sources. And this top level data structure can take on different forms. It could act, as it could be like a list index, which is like a summarizer. Basically, it can, it'll route the query to each individual data source, but then combine all the responses into one response. It can act as a router where it actually picks like a subset of these sub-indices to actually dive into. And then in the end, it'll synthesize a response from the sub-indices. But basically, just imagine, say, you have some parent node as a graph, and it can route it to some, data structures as sub-indices, if you will. And so if you choose to, you could wrap this entire graph, including the parent node and the child nodes, into one GPT Index data structure that you can then, say, query for summarization or as a query for question answering. And then we'll route the queries underneath the hood, right, based on your graph to actually synthesize the response that you want. Hopefully that makes a little bit of sense. But the idea is that you can kind of allow users to define some graph, quote unquote, structure of your data to kind of, define hierarchies to solve the task that you want. And at the end of the day, it's just allowing you to be able to query over some data, and then you're able to get back the response that you would want. The integrations with other tools, for instance, like LangChain, is a separate component of this. So for instance, like one thing that a lot of users are trying to do is, let's say you define an index structure over your data. Let's say, you define just a simple vector store based index over your Notion notes or your Slack conversations. But let's say you're building a chatbot, right? And you want to use like LangChain to do that. So you can build a LangChain chatbot, which will maintain your conversation history. And this agent will also try to look up or try to use different types of tools in its repertoire to actually perform different actions or perform lookups. So you can actually add these indices as tools within, kind of like the set of tools that an agent can use, so that with this abstraction, every time the agent is trying to reason about a step, it can choose a tool that will help it perform, that's like the best tool suited to perform the action that's requested of it. And this tool could be a GPT Index data structure, right? And again, going back to the fundamental interface with GPT Index is you can pass in a query, right, some request, and you'll get back something out of it. And this tool could, like this GPT Index data structure, could be arbitrarily complicated, could be very simple, like just a vector store index, or it could be an entire graph structure underneath. But an agent can choose to, basically use this as a tool to get back the response as it needs. At a high level, you can basically think of this as, one thing that like the agents do really well is that they can do multi-step reasoning. But you can treat GPT Index as one step, right, of this multi-step reasoning to retrieve the information that you would want.
Interesting. So while you were talking about this, I have a quick follow-up question related to that, because the it for me, making like these tree structures, that makes a lot of sense to me. It's also, I find it super intriguing in how you walk down the tree basically to find the answers. I have two questions about that. So one is like, let's say that I have like a large document, because actually this is something I don't know. Let's say, I don't know, like really large, like 100 pages, something, right? Or like 100 paragraphs. That's maybe easier. What does how much inference is it doing on the model to find the answer, and how much time would it take just to produce an answer? So how often are we talking to the model? How often is GPT Index able to know where it needs to traverse to? What are we talking about here?
Yeah, so no, it's a good question, and I think again, this probably warrants like a broader discussion about some of the trade-offs you make when defining these graph structures, especially with the current state of GPT. Imagine every node of whatever graph that you define, right? If it's a tree structure, let's say you have two levels, like a parent node and child node. Every node is going to require some LLM call, maybe two, right, to GPT. Now, um, you know, there is some sort of like practical like cost and latency trade-off that you're going to have to think about when you actually define these complicated graphs over your data. Because I think conceptually it's very interesting. It makes a lot of sense. But every call to GPT is going to take around like 2 to 3 seconds if you just give it like 3,000, 4,000 tokens, right? And it's going to incur a marginal cost as well. So there are just some practical constraints in making this graph overly complicated, because the more nodes that you add and the more nodes that GPT Index has to traverse, the more LLM calls there are going to be, and then the kind of longer you're going to have to wait for your response. So I think for a lot of tree structures, practically speaking, what has worked well are just slightly more shallow structures. So a vector store based lookup actually makes a decent amount of sense, because actually for an embedding based query, you don't really need to call the LLM at all, right? You just do a dot product, and the only calls you need to make are to the embedding model during construction. And then maybe a call to the language model finally, if you want to like synthesize an answer, right, from the set of nodes that you retrieved through embedding lookup. So embedding lookups can be a pretty practical, like cheaper alternative to that. But I think, yeah, generally speaking, hopefully as these models get better and cost and latencies does come down, this notion of repeatedly querying or recursively querying the LLM for more information has already proven to be pretty useful in a lot of cases. Like if you think about just like chain of thought prompting, React, traversing through knowledge graphs, it's evaluation. It's all very interesting. But that stuff will be more possible once we solve some of the practical constraints.
Yeah, and I'm actually, this is so interesting because this goes back to the thing we just discussed about that we're looking at how can we use basically the LLM to just also feed data back into Weaviate. And what I like so much about GPT Index is that you support like these graph connections. So something that I'm super interested in like also further figuring out is that rather than just having this combination of GPT Index and then Weaviate as a vector store, that storing these connections as well. So basically, that if you do the query like for the first time, it needs to go to the model, needs to figure it out, but it can not only store, for example, the embeddings, but also the graph connections that it's making. That is something that I'm super excited about because I would not be surprised that this year we're gonna see this trend of the term that I'm now using is just creating a feedback loop back into the database using tools like, for example, GPT Index, and I find that super interesting. I would not be surprised if we see some prototypes in the near future exactly doing that because then you could even say like, hey, GPT Index, I want you to figure something out for me. I'll be back tomorrow. And it starts to traverse, it starts to do lookups, it starts to add stuff to the database. And then the next day you see all these graph connections and relations in the database. And now you can fast and quickly traverse over it. I find this very intriguing. It's super interesting. Super interesting.
I find it very interesting too. I mean, I think if once these part of this is the bet that these models will get better, faster, and cheaper, and then you can start using it to really automate some of your more of your kind of like data ingestion and transformation pipelines, and reduces the human workload on really thinking about, okay, what is the best structure over your data, right? Because a lot of data engineering, once this does get better to some degree of quality, will can kind of hopefully try be solved somewhat by being able to infer a lot of these relationships automatically, right, as opposed to manual definition. I think I'm very excited to see where this goes. I think like just kind of like with a grain of salt, there are some practical considerations just because it is I think, important to define some performance bar, right, over like what is the acceptable level of quality that you're looking for. Like, for instance, if your data ingest pipeline using GPT is actually, making mistakes like 10% of the time, like that might be too high, right? And then the question is thinking about how can you think about some interface where, maybe it's not automating all of it. There's still some like human feedback in the loop, but it's automating like a good chunk of it, right? And then it can actually help empower and speed up like users' workflows and actually building out some of these pipelines. So a similar analogy to this is, why, for instance, something like Copilot or Notion AI are popular, because they allow for mistakes made by the model, right? And so you do want to probably put this as some interface where you can still allow the model to make some mistakes, because, the model is great, but it's not perfect. It makes a lot of mistakes. So how can you make sure that the errors don't propagate and that you can kind of correct errors right now? I think that's going to be an interesting interface to think about, and probably something I'm thinking about for GPT Index as well. And the hope is that as these models get better, you're going to have to do a little bit less of that.
Yeah, I have one more follow-up question about that because it's so interesting. So if we switch gears a little bit from you working on GPT Index more as like the the project, you also need to design it, right? So you're designing like the interface, how people interact with it. Um, what kind of things are you taking in consideration for those who want to use GPT Index really to build like production solution, right? So are you taking it into consideration right now, or like no, I'm just parking that? Let's just first things first and then do that later. Or I would love to learn how you're thinking about that.
I think I think uh, I'm somewhat parking that, and the reason is because I haven't dove into the full brainstorming about how to really solve like how to automate like data ingestion and transformation. I imagine once I really start thinking about that, then the notion of how to evaluate performance and how do I correct errors, those types of things would become more important. I find that for the basic use case that a lot of people are using right now for GPT Index, because the construction of the index is still kind of manually determined by the user, a lot of the end use cases are, for instance, for like summarization and search. And for a lot of the current use cases, it's actually okay to make some errors, right? Like, people use like recommendation models, ML models, and search all the time. And part of the appeal right now is you can actually just do search and build that type of tool a lot faster with something like GPT.
Very interesting. Very cool. And for those listening to this podcast who are responsible for building and serving these models, you all know what to do. We need some speed.
Yeah, I had one question. I want to jump in on the correcting the errors. So one thing that I've been thinking about is like with the cost, like you might, instead of using DaVinci 3, you might use like Ada or something to have like, because it's cheaper, and then you can sample like 100 outputs and then re-rank them with these ranking models. So what do you think about that kind of idea where you use a lower capacity GPT, but then you generate a ton of outputs and then filter, re-rank the outputs?
Yeah, I mean, I think there's a lot of approaches to dealing with that right now. I haven't been able to explore this fully, but I think that at a high level, the idea of, say, building some optimization layer that can have a reliable estimate of performance, uh, but also give you, predict the cost and that satisfies your compute budget. Building the optimization layer is absolutely something I want to start working on. And so whether or not that includes, for instance, using like cheaper models and stacking it with like better models, right? Or whether that's a notion of just like, how do I try to best like evaluate latency and how do I speed that up, right? With respect to, for instance, like async operations or other techniques. Those are all in consideration for this idea of optimization. Because I think right now there's like a grab bag of different techniques that people can use to try to like both make things a little bit cheaper and also a little bit faster. Ideally, what I'd want to do is provide an interface to make that as accessible as possible and also adaptable as these models get better. Because the idea is some of these techniques might become out of date as these models get better. Like one of the examples is the OpenAI embedding. Like before, like OpenAI released like text embedding Ada, right, like 002. Like it was just infeasible to actually use OpenAI embeddings. Like I ran up a $20 bill going through like 2 or 3 documents, and then all of a sudden with these embeddings are like 99.98% cheaper, it's just a lot more feasible to use this to index a lot of documents. So I think we do want to make this provide some general tooling to help people decide between cost and latency, and we also want to adapt this tool to future advances.
Yeah. How much are you connected to GPT models, right? Because it's in the name, right? It's a GPT index, but a lot is happening there. So is that just are you like married to GPT models, or are you just open to also explore other things?
Bob, that's actually a great question because, I'm going to use this opportunity to say that we are actually going to undergo a name change. Probably, within the next few weeks, it will be gradual. We'll support some sort of backwards compatibility with this package of GPT Index that everyone's familiar with. But yeah, so we are very much trying to. I mean, the tool itself is already general, but we're trying to also position it as more general. Um, Already, like, GPT Index right now supports different LLMs besides just OpenAI models itself, right? You can plug in basically any sort of LLM from Hugging Face, Cohere, AI21, other model providers, and you can also plug in different types of embedding models as well. We do want to be a general tooling layer on top of like different LLMs, right, as opposed to being tied to a specific service. Also, changing the name and making it more general will help us avoid some trademark issues. So very excited to start kind of keeping you posted on some updates for this.
So are you gonna keep us waiting, or can you already share what the name will be?
You know, I will give you a hint in that we released Llama Hub about 2 days ago or yesterday, and we like llama as a prefix, and I think that's what I'll say there.
Okay, that's fine. That's fine. That's we can work with that. Thanks for sharing.
Yeah, that's great because LLM, it's too like, there's no vowels in the middle of it.
No, exactly. Yeah, I love the name.
I think that'd be a great thing if we could talk a little more about Llama Hub. So I had a quick look at it. It's like a hub for external data sources. Can you tell me more about it?
Yeah, exactly. So maybe to frame this a little bit better, part of GPT Index right now is the way you can define complex relationships over your data. But really, the higher level mission is, again, to define this best interface over your data, right? And one thing that we've been noticing, especially as people have been starting to use GPT Index, is that it has this entire pipeline has a potential to kind of alter the data analytics landscape. Like if you think about just the amount of work it takes to ingest data, right, and the data engineering pipelines in place to ingest, transform, store data, and then transform those into insights that you get to the end user. There's like multiple companies and billions of dollars within each of these components, right? So within like 5 lines of code within GPT Index right now, right, you can basically build a search bot. You can ingest your PDFs, right, convert it into some text. And the beauty about GPT is that you don't have to make that text super structured. You just need to provide some information about it. And then the worries that you have are more about like text trunking and how to actually provide this information. And then you store it, in some format, whether it's Weaviate or some more structured database, and then you just ask GPT to answer questions, right? And then GPT can handle translation to SQL or just directly using the raw question to answer your query. So there's just a lot of kind of interesting things happening around this idea that I think if once LLMs do take off, this entire pipeline will be able to change and actually become kind of like a lot simpler and just more automated. And one of the key components at the beginning of this is this idea of data ingestion, right? And so I think one thing that's been really cool, a really cool component of GPT Index so far, is we've seen users submit a lot of community-built data loaders, from PDFs to, for instance, HTML documents to PowerPoints, to web pages and APIs with pretty much a lot of the popular integrations like Notion, Slack, Discord. We have a GitHub integration coming soon as well. And it's really, the thing is, it's actually not super hard for users to add these integrations because what they have to be worried about is just not like doing all the ETL into a structured database. They just call or connect to this API, and they provide the information as raw text, maybe with some annotations on top, right? And then the question is just, okay, now how can you feed this into something like GPT Index, which can ingest this raw text and do text splitting and store it into an index data structure.
Sorry, yeah. So if you look at the the software stack, right? So where you have the user on top and then core infrastructure on at the bottom, right? So you have the whole stack, and then for example, so Weaviate is a little bit lower because it's like a database, and then GPT Index is a little bit above that, closer to the user. Do you think that GPT Index would evolve also more like up the stack? So because I was very intrigued what you said about like also all these data loaders that people are introducing. That is interesting because that would allow you to have like this whole marketplace basically of data loaders. Or are you more interested in moving down the stack? How do you see that develop?
It's a good question. I don't really see myself or GPT Index moving down the stack anymore, right? At least at the current moment, because like Weaviate knows, you guys know how to create like scalable, like high performance like databases, right? And part of GPT Index's appeal is actually just being able to integrate with, for instance, you guys to actually help users build an app, right, for on top of their data. I could see us expanding both horizontally and maybe a little bit kind of up the stack as well. And I think data ingestion is one of those pieces that very much fits within this philosophy, because we build this marketplace or this community. It's not really a marketplace, but like a community-driven hub of people trying to submit, just submitting different types of parsers and loaders for different types of applications. We can try to have them use GPT Index with this data loader, or you can actually use this with LangChain as well. And what it actually does a few things. One is, we provide the central platform for them to then ingest this data. Then, whatever the storage and kind of like of this data is, it could, very well be Weaviate. And then the other component of this is that by kind of creating this community of data loaders, we can help almost like educate users on the value of LLMs. Because now, you can actually have people thinking, hey, like, it's not like I only need to just feed in my text notes, right? It actually turns out like with technologies, like not even just GPT or LLMs, like by combining stuff like Whisper or like image captioning models or any sort of, models that basically convert unstructured data into text, we can actually build this end-to-end application starting from this very unstructured data into something that you can actually translate into insights. So I think that is very much something that is part of our vision. And I think the first part of that is super important as well.
Yeah, wow. I think I think that's a good coverage of the topic. If there's anything else you guys want to add.
I mean, you shouldn't offer that because I can keep talking for 2 more hours about this. So it's like, this is just too exciting stuff, man. Too exciting. Yeah.
Well, maybe I want to throw this in quickly before we wrap it up. Is like, how about the extension from text to images and multimodal? I just love this topic because I think we're So we saw the diffusion models, and I think a lot of us predict that we're headed towards this boom and image, audio, video, 3D images, all that.
Yeah, 100%. I mean, I think um, I'm still kind of trying to brainstorm use cases, let's say for text to image, like what that would look like. And, this is just me spitballing off the top of my head. Is it like, oh, you want to be able to reference like a corpus of existing data that's also images so that you could generate a new image? Is it that you want to be able to reference a corpus of text descriptions so you can generate a new image? I'm definitely open to the possibility, at least in terms of including some components of that. I will say though, in terms of like storage or converting from like say images and audio to text, that's actually part of this idea of Llama Hub and actually something that we want to push for. Imagine if you can just take in some different types of data, right, that are not inherently text on their own, but you can convert them into a text format that makes it pretty easy to search and look up without doing too much data engineering on your side. I think that could be a pretty valuable application.
Yeah, it's incredible. Do you see like maybe even like brain computer interfaces, like that kind of data being translated and GPT Index going through your brain scans.
Yeah, no, I mean, I think, a lot of the heavy lifting is done by these models that are doing these conversions, and we're very excited to keep tabs on the advances. Like, for instance, we integrate like OpenAI Whisper, we integrate like the Donut model, which does like kind of OCR. We're very excited to try to include this. And now the question is, how can we, wrap this in a layer that makes it both easy for people to build apps on top of it, and then two, make this scalable and performant, right? Because some of these models do have GPU and performance constraints.
Yeah, and one more as I'm like doing this list. What about robotics? Like, have you seen the SayCan, like kind of how much these advances in text processing are impacting the robotics generalization as well?
Yeah, it's interesting. I mean, I kind of came from a world of self-driving research before my current role, and this is a few years ago. And I think so far, I think it's been somewhat decoupled. Like, I think you'd store, for instance, like image and LiDAR data as you know embeddings on its own. You don't really think about like converting it to text. So I think, for practical reasons, there's probably ways to just like store different types of data in their own formats. But if, we start to see these models become just, again, faster, cheaper, better, like I could see text being a bit more universal of an interface for storage. And then then you could build a bunch of applications on top of this.
Yeah, incredible. Well, Jerry and Bob, thank you so much for coming on the Weaviate podcast and for having this discussion. I saw Bob recently shared a meme where it's Patrick from SpongeBob. His head is exploding, and that's that's how I felt this whole time. I think this was just such an information-heavy podcast. I think this sub-index tool use, this routing thing, is just one of the most exciting emerging technologies, and we're so grateful to have you on the podcast. So thank you so much.
Yeah, fantastic. Thank you.
Amazing. Thanks, Bob, and thanks, Connor.